So this is objective 3.3a, and we're going to be working on variation problems for the rest of Unit 3. 3 sections of notes that you'll be taking on variations. It's kind of a random topic, doesn't really go with the other things that we've done in this unit, but had to go somewhere. So we put it here. So our instructional objective today is that you will be able to identify the proper variation equation and then solve for the constant of proportionality, or the K. This is very formula-based. You pick one of the 3 formulas and you plug information into the formula and you have your solution. So it's just a decision-making process more than anything. The math skills that you need are very basic. It's just making the decision that you need to be able to do. And I don't think this is going to be a problem for anyone. There's some vocabulary that's really important. And I'm not giving you the definitions of these terms. I'm giving you the words or the things that these terms ask you to do. So when you see the word varies, you're being asked to write a variation problem. Okay? A variation problem. Another word you could see is like a proportional situation. It'll also tell you to write a variation problem. If you see the word direct, directly, any version of direct, you're going to multiply. So direct tells you that you're going to multiply some numbers. Okay? If you see the word inverse or some form of the word inverse, it is directing you to divide. Okay? If you see the word jointly, it's asking you to combine 2 things through multiplication. Combine 2 things through multiplication. And then the big deal is the constant of proportionality. And that's your K term. Okay? So you will be always finding this term first, and it is a constant term. You're given some numbers, you find the K. The K remains constant, exactly the same number for that problem. So it is a constant problem, or constant number. It's unchanging. It is always what it is. X's and Y's can change, but the K does not. Okay, so that's the terminology. What we're going to do now is I would like you to look at the list of the different, let me get all of this off of here. If you would please add this 4th term to your note page, combination variation. I printed it before I caught that it wasn't there. Okay, so what we're going to do is I'm going to give you some key phrases that tell you you're going to write a direct variation equation, or an inverse variation equation, or a joint variation equation. Okay? So, we're going to start with the direct variation. This variation is linear, meaning it'll graph a line. Y equals mx plus b. It's a line. Okay? So, let's do this. It'll be helpful when you're doing your assignment on Monday to know this information. So we'll draw a little XY table, and it'll have a line. Okay? So the direct variation is going to create information where the X goes up and the Y goes up, or the X goes down and the Y goes down. There's a direct relationship between your X and Y. Okay, and here are the 2 most common phrases that you will see that will tell you that you are going to do a direct variation. So the first one is Y varies directly with X. You don't want to write that down. Y varies directly with X. And that's important information. It's going to tell you how to write your equation. When you see the word varies, it tells you that y equals, varies tells you it needs a k, because it has to have a constant of proportionality. So varies means equals k. So y equals k. And it varies how? It varies directly with this term right here, x. So remember what I said when I told you what directly meant. It means you're going to by x. That's what that means. Another way that this could look is this. Y is directly proportional. Well, is means equals. Proportional means that you need a k. Okay? And then there's the direct connection to x again. So you'll be multiplying times x. So this equation looks like this. Y varies directly with x. Linear. The k is your slope. Instead of mx plus b, it's just a kx. Okay? So you're looking for the word direct to tell you that this is your setup for your equation. Okay? Next one is your inverse variation. And this is going to create a rational equation where there's a variable in your denominator. Okay? So this looks more like this if I'm going to graph it. Rationals don't graph lines, they're inverses. It's like y equals something over x. So it'll graph, I think I'll change colors here, a shape that's a curve that will approach your x-axis and y-axis, but won't ever reach them. Okay, so it graphs like that. Again, that's important to what you're doing on Monday. And then here are two terms. Now, very, very similar to the other two phrases. Again, you have y varies. So varies means what? Equals. Okay, thank you. Inversely with x. Inversely means I'm going to do what? Divide. So let's write that. That's y equals k. What do you think? What am I doing with k and x? There it is, k over x. So that'll be your setup. So your k will be in the numerator, and then the number that's being compared inversely will be in your denominator. And it's the same thing down here. Y is means equals. Proportional is your k, and inversely to x, that's divided by x. Okay? So those are the two terms that you'll typically see. They can come in other variations. Haha, get it? Variations. But you'll always see the word inverse or direct or possibly joint or maybe a combination of both. Okay? Then with joint variation, I'm not going to write all of the versions of it because I think that you get it by now. But here's the a phrase you could see if you're being asked to do a joint variation type of equation where you get y varies. What does varies mean? Equals k. And then you have the word jointly. So jointly means you're going to join two numbers, right? So you're going to join x and z with a multiplication. Okay? So what does that look like? What do you think? K, x, z. All three of them. And now that throws a third dimension in the problem. It's got an x, a y, and a z. So it wouldn't go on an xy table. It'd have to go on a three-dimensional x, y, z table, which we're not going to try to tackle right now. Right? So that's enough information for that. Then the last one is the combination variation. Now, a combination variation just means you're going to combine these, any of these, all three of them, two of them, it doesn't matter. I'll give you an example. This is not, by the way, the only example of a combination variation. This one's just a really basic one that says y varies directly with x and inversely with z. So again, you see that word varies. That means equals k. That tells you it's a variation problem. And then directly with x, that's multiplication. Inversely with z, that's division. And so, what do you think that one's going to look like if you had to write that equation? Take a chance. Come on, I like chance risk takers. Y equals kx over z. You've got it. And so that's the biggest skill that you need in order to do these variation problems, is to develop the proper equation. So you always want to have them written down so that you can refer to them until you, of course, memorize them. And after you do so many, they do just kind of get stuck in your mind. Okay? So here we go. We're going to start with this one. So today's focus is basic. Just find the constant of proportionality. Find k. Find that number that is unchanging. That's all you have to do. So we're going to start with this statement that says y is, that's equals, right? Directly proportional, so that's your k, so that tells you it's a variation problem. And directly proportional, so x means we are multiplying, right? So we're going to write our equation that looks like this, y equals k times x. So we have identified the formula or the equation we want, and then all we're going to do is we're going to go plug in our x and y so that we can find that k or the slope of that line, whatever it is. So let's go with 27 is equal to k times 42. This is where your calculator will come in really handy because we just isolate for k, right? Divide by 42. This feels like 7th grade math here. K equals, you plug that in your calculator, it's going to tell you the answer is 9/14. I do want your answers in fraction form because I want the exact answer, and sometimes decimals aren't exact. So that's how you do that. And that's about as difficult as it gets. Okay, next one we have I is, there's that word is, that's equals. There's the word proportional, so that's k. So I is inversely proportional to r. So that looks like this. I is equal to k over r, because you're going to divide by your r. And then you just plug in the information. 55 is equal to k over 33. And you solve for k. Now to do that, we would multiply both sides times 33 times 55 equals k. So k equals 1815. And so now, for all of the problems or all of the numbers that revolve around question number 2, your k will always be 1815 for that specific problem. So if I wanted you, if I said r is 45, find I, now you could do it because you just multiply 1815 times 45 and you'd know your I, which is where we'll go after today, but not today. We'll keep it really basic. Okay, here we go. 2 more. So the next one we have is E varies jointly with I and R. So varies means equals k. I don't want to do it that color. Varies means equals k. And jointly with I and R. So that means we're multiplying them. So how would that equation go? K I R. That's a lowercase k, but anyways. So that's your equation. And then, of course, you just plug in your information where it belongs in your equation. So 225 equals k times 75 times 125. And I gotta tell you, I would not complicate this process by multiplying those two numbers together. I would not, because you have your little calculator that will do the math for you. So you're going to divide by both, right, to bring them over here. I personally would just plug that straight into my calculator because it'll simplify it, it'll do everything I want it to do. And I believe we get 3 over 125. And make sure that you practice that. Do you need me to put the calculator up on the board? Anybody? Anybody? Speak up. Be a squeaky wheel if you want me to show you. No, you don't. You don't have to do that. With these little calculators, I am going to show you. With these little calculators, come on, open up. Come on, video. Take it for little calculators. You just pick your numerator over denominator, like so, and then you type in your numbers. 225 over 75 times 125. Am I right with those numbers? And then hit enter. 3 over 125. It's done. Don't complicate this process by multiplying things out. I know you know how to multiply and simplify. We don't need to practice that. Okay, back to work. Last one, here we go. Y varies equals K directly with X and inversely with Z. So what kind of variation is this? It's a combination. You got a direct and an inverse. So it goes Y is equal to K times X over Z. So I should have written that in black, but I'm not going to. Okay, I'll do the other part in black. So then we just, of course, substitute the information so that we can find our constant of proportionality, our K. So we get 12 is equal to K times 24 over 60. And again, I would like to point out that we can use the calculator to do everything we want it to do. I've been noticing all day that people either pay attention to me and they get this done in one step, or they do it in 2 steps. So I want to talk to you about how we would solve this in 1 step. I want to move the 24 and the 60 at the same time and leave the K isolated. What's my process? Times 60. That only cancels the 60. I want to cancel the 24 and the 60. Okay. So, nope. Okay. So here's what we're going to do. We're going to do K times 24 over 60. To clear the 24 and the 60, I'm going to multiply it times its reciprocal so that I can cancel them both at the same time. I can always multiply by the reciprocal of a fraction to clear it. So times 60 over 24 so that I can cancel in 1 step. And then I can plug this directly into my calculator. Directly. Exactly like that. And it'll do the math for me. Calculators are genius. So what was it again? 60 over 24? Times 12? 30. Done. No big deal on that. And so we get K equals 30. So be efficient, I can say words sometimes, an efficient user of your calculator. Don't waste time multiplying things out when you have a tool. I know you can multiply and divide. We don't need you to practice that. Okay, so that's it. So we were going to work on problems 6 through 22. However, I do want to remind you that there are some problems on there that I did not address. They were the proportion problems. And I just want to review, how do you solve a proportion? So if I were to give you this problem, x over 3 equals 4 over x plus 1. And I wanted you to solve that proportion, which is a fraction equals a fraction, for x. What would you do? You could do that to clear the fraction, or because it's just a fraction equals a fraction and there isn't anything else, you can just cross multiply. X times x plus 1 equals 3 times 4, 12. So that's the fastest way to clear the denominators from a fraction equals a fraction. We call these proportions. So the fastest way to handle them is to just cross multiply and set their cross multiplications equal to each other. Your extremes equal your means. So x squared plus x equals 12. It is a quadratic. Therefore, you must make it equal 0. Right? And then you got to factor that baby out. So splitting our x's, what are our factors of negative 12 that add to positive 1? Positive 4 and negative 3, right? And then, of course, setting them equal to 0. What's your 0 for x plus 4? And your 0 for x minus 3. And there are your solutions. Okay, so that'll probably be the most difficult problem you have to do, something that's similar to that. So when you see your proportion problems, that's just a review. That's something you're supposed to know how to do. So I'm done with the video, which is